Hello and welcome to my video. By the end of this video, you'll be able to play a game with the computer. However, I may miss some things off. For instance, if you make a move and the computer's thinking, you want it to be able to, you want to block all other moves until the computer finishes. Okay, so I probably won't put them things. And there's other things that I may not put in. However, if you're not trying to break the game, you'd be able to play a game. Okay. Now, if I open up the console, we'll click on the square. We set all this up at the beginning, where whichever one I click on, it gives me the number. It gives me a number. Okay. So this is a 5x3 board. So I'm going to show you a 5x3 board. I'll show you what's going on. So that is what we've got. We've got a 5x3 board, and if we click on any number, okay, I'll click on these end ones. You get 4, 9, and 14. 4, 9, 14. Okay. Now we've got a problem because the other system uses this board. So when we click on that 0, we need 8. So we need to convert between the numbers, but we already got something that does that. So what we'll do is I'll move that aside, and what we'll do is another thing as well. This is text, but we want a string. So what I'll do is we want the column. What we're going to try to do is get the column equals, but for the time being, I'd go through it bit by bit. First thing we have to do is convert that to a number. And I'll do it like this. Number E. So that's the first thing we have to do. So let's test it. So it's now giving us numbers. Okay. Next thing I have to do, when I click 0, I need 8 and 5, 15 and 10, 22. Okay. So what I'm going to do is I'm going to use my favorite new thing, my favorite new toy, which is a deconstructor function. The bottom equals this dot AI dot game, because that's where all the objects, that's where all this information is stored. So what I need is convert to, which is this, because that's gonna contain the thing to enable us to convert between the two of them. So if I go back here and I put that there, so now I can do that, and I can do that. So now I've got the convert to. So what I'm going to do is clear that. So let's see if it works. So I'll click the last two again. 1, 2, 3. Let's check. I've got 12, 19, 26. Okay, so that works. Now, remember when we played that game before, we're using human move. Before I do that, I'm going to shut that down. Human move. Get human move. So what we used to do is we used to enter the column. Okay, and I used to use make move to make the move for us, because obviously when we click here, we don't want it to make a move here, we want it to drop down, just like in a real game. So the validation we had to check is whether it was a valid range. However, we can't make a mistake here because it's the board. We can only move what's on the board, so we don't have to check that. We only have to check that the square is available. So that code there, we're going to use this at some place to check. We're going to use this code, and that's going to check if it's the legal move. Okay. So now let's go back to the other thing. So we need the column. So we need to get the board width. That's the proper board that the AI uses. And once we get that, we can do modulus with the board width. And can you see how that's yellow? That means that it doesn't recognize it. So it should be, this should be easier to spot errors. So I've just got to use my deconstructor to get it back up. So now we should get the columns, but what I'm going to also do is I want to also log which one is pressed. So okay, let's press on them. That's one. So that's all ones. That's two. So it's working. It's give us, so now we've got the column. So it's just simple now. We just get other stuff from here, like, and then we run some function. But what it is, from here we go from here. Can you see here? We're going into this object and we're getting things out and we're running them and then we're bringing them back. Okay, and that's not really a good way to do things. We get, because we're running there, getting this, then we say, okay, what do we need here? We go here, we look, we need this, come back. What we need to do is go in that other place and run all of these from the other place. Okay, so what I'm going to do is I'm going to take all of this code out, because what it is, that's the thing about programming. I could carry on doing this, and it probably wouldn't make any difference to performance, and it will work. So new programmer, if they was going to program this, and they would just do it whichever way, and it doesn't make any difference. However, doing it this way is making it easier because it's grouping things together, and that when the programs are bigger, then that's when you see the difference between doing it this way and the other way. Or otherwise, now you probably won't see the difference. Okay, so what I'm going to do is I'm going to take all of this code out because it's in the wrong place, because it's getting things from other objects. It's going here and saying, can I have these? And then it's using them. Then it's saying, can I have more things? When instead of doing that, it can actually go to the other objects and do it in the other object. So what I'm going to do is I'm going to go to that other object, which is this, and I'm going to create a function here called human move. And it's going to take the side, and it's going to take the square. Okay. So the first thing I'm going to do is I'm going to use my deconstructor, the new deconstructor. That's going to make it easier, just a bit easier for me, because otherwise I'd have to put this start game, this start this, this start convert, this start board, this start this. Sometimes you have to do it. So you have to be careful when you're using this. That's the array. So that will pass a reference. So that will be okay. that is also an array, so that will be okay. This is a constant, so that will be okay, and this is a constant. So I'm not changing values. I'm only reading them. So, but you have to. If I was changing values, then I would then have to put this dot game dot board ww and etc. But you just have to be aware of when. For example, if I go to min-max, here I'm doing this game dot positions plus plus. That's because I'm writing to it. Because I'm writing to it, I can't deconstruct it because I'm not because. But if it was the board, because the board is a array, and I get past a reference to it, I can change the board and it will change the board there. But with this, when I get this variable, it won't change it there. So you just have to know about that when you're using this. Okay. So I'm just going to get these out because that's what I'm going to need. It's just going to make it easier. So the first thing I'm going to do is, it's going to be similar to the computer one. We need something for the winners. If I win, I need to know which square won. And then I've got to convert that. I've got to convert that square to an index, and that's on our new board. And then once I get that, I can convert it to a column, which is what we've done in the other place. So convert it to a column. Okay. And then the other code I showed you, which is here, we need to see if it's a legal move at this stage. So I'm going to put that here. So I'm just going to copy and paste it in. So at that stage, it will know if it's a legal move or not, and if it's not a legal move, it will simply return false to us, and then we handle it over at the other place. So that means if it gets past that line, we know that we've got a legal move. So what we have to do is we have to make the move, and we make the move there. But what it is, as you know about this make move, we put a move, we click here, and it just drops the move down, but we don't know what it is. So what we have to do in this make move, we have to change it slightly. And all we have to do is we have to get it to return the move that was made. How do we do that? Okay, we simply return the index. That's all we do. Here it is. That's where we make the move. Wait 1 sec. Yeah. So actually, that's where we make the move. So we just have to return the index. So all I have to do is and that should return the index now. Now what have I done wrong? I didn't think I would. Oh, that's what I did. I took all of them out. So what I need to do is Put it on there, yeah. So we'll just return the index. Okay, so that's done. So we will make the move, and we actually know what the move is. Then what we then do is similar to the computer one, we make a move and then we create the result, which is whether there's a win, whether there's any squares left, the side. I mean, I probably won't use the side. I don't think I'm using the other one. And the best, which is a move that we made, whatever that move was. And just in case it wins, just in case there is a win, we need to see what won. So similar to the other one, what we have to do is this is called from the other one. The computer move. You've seen all of this before. If result valid not equal to null, winner equals this. Find winner best. Winner push best. So it changes. If I won, then we'll change the board. And then I just have to return the result. Okay, so I'm going to return result here. Okay, and that should be it. So what happens is I'm gonna make a move, and it's gonna tell me whether this object will tell me whether it's won. Okay, so all this gonna pass it to it is a string with a number in it. It's gonna do all the work like converting it. It's gonna make the move. It's going to see whether it's won, and then it's gonna return this object back to me. Okay. So that appears we're finished now. So we just have to go back to the other one and sort it out to make it work. So what I need to do is I'm gonna use my destructor. So I need to get the side from the enum to see which side is the side. So every time you click, what I need to do is that function that we just created. I need to go in there, call it with the side and the key that was pressed, which is this. So I need to pass that in, then it should pass back an object. So what I need to do is, after I do this, it will actually make a move for me on the other board. Okay? So what I then do is, I need to see that move made on this board. Okay, so what I have to do is, I have to cause a render by doing that. Start game. That will cause a render. Let me just go to start game and show you what it does. It go and gets that board, so it gets the board from the AI, it gets that board, and then it sets the state, and when we set the state, that causes a render. Okay, so then we'll see the move that we made. So without us putting that there, we won't be able to see. It will make when we run this line, it will either come back as false or it will make a move from us. Okay. At this stage, if it didn't make a move, it was illegal, then it wouldn't make the move. So when we do this start game, there's nothing changed because nothing's being moved. So that won't do anything. So it doesn't matter that we've run this start change early. Okay. And the last part of it is you have to do an if else. And because we've only short a time, I'm going to paste it in. Okay. I'm going to talk about it after I paste it in. So now we made the move. That line renders it. And now we do all of this. So it's passed back the information. If legal move equal false, we're just going to log to the console for the time being. Okay, we're going to log to the console illegal move, and that's all we're going to do for the time being. Because we just want to get the game playing. Else, if legal move eval not equal to null, that means there's a winner, and it's us because we just made a move. Then it's going to call winner with the side. Else, if the board is empty because of that, because there's no more moves to be made, then we say draw, and there's no win, that means the draw, so it will do that. So if it gets to here, that means I've made a move, no one's won, so it's just got to do one thing, and that is get the computer to move, because it's the computer's turn now. So what we can do is we can do this start force move. And that should be enough to for the game to run. So I'm now going to try it, but I'm going to try it with a different board than what I had before. So what I want to do is I'm going to play a game that we played on the other board. So I'm going to set it to 7 by 6, and it's going to be 4 in a line. Okay. And before I go, let me just come here and test and see something. Get computer moved. Oh, the wrong one. It's this one here. What I've done in this one here, I added some lines in it. So that's performance. I want to see how long it takes to make moves. So what I added these extra lines in. So what it does is it will just measure how long the AI takes to move and tell you in milliseconds. So after each move, it will say how long. Okay, so now we'll make the moves. So let's do a reset. And let's move here. Okay, seems to be working. Okay, let's set the... I made a mistake on this. I wanted to set the depth to be a bit deeper. It only took 77 milliseconds to make it move. But anyway, maximum depth of 4. So I want the depth was 7 before, so I want to test it on the depth to see whether it does the same thing. So what I need to do is set the depth, and the depth is controlled in that object called enum, which should be called something else really, but all right, what was the depth? Was it 7? Let's set that to 7. Okay, so that's set to 7. And let's try our game out. And as you can see, I click the board, and he hasn't showed it. It's not showed on there yet. Can you see what it's doing? The behavior of what it's doing. When I click on the move, it doesn't show it. And then when the computer plays, it shows it. Can you see? I clicked on the move. So it's sort of waiting for the computer to play. Now this is a known issue with React. And the reason it's doing it is it's because how React works is the render function is asynchronous, so it doesn't block the code. So what it does is, when I do this set state, well, I'm concentrating on the code now. Wait there, I can't move up because it's thinking, so I'm going to wait for it to stop thinking. Okay, what was I going to look at? When we do the start game, it comes up here and it does this set state. Sorry about that, my phone then. Okay. When we do set state here, it doesn't block the code. So what it does set state, and then before it can actually start, this line carries on. It does that. It goes through here quickly, and it comes to here where it does force move, and set state sees that some other process is taking up 100% of the processor. So what it does is it says, okay, I'll delete. So it doesn't do it, and because of that, so to get around this, what we have to do is we have to stop this running straight away so that set state can actually render in time. So what I'm going to do is I'm going to scrap that game. I'm going to do that. So we do a set timeout, and I think 50. What is it? 50. A human cannot detect 50 microseconds. That's a 20th of a second. So it's got 50 microseconds to render. So it should be able to render the page in 50 microseconds. Okay, so that should now fix it. So all I'm doing is I'm delaying. When I make a move, it's going to delay for 50 microseconds so that the thing can render. Okay. So now that that's in place, let's see how our game goes. So now I'm going to play the exact same game that I played on the console. Should be exactly the same result. Whoops! I nearly lost then. I only got there. So I can click, as in the other game, I can click anywhere here and it will just register as we all want to play. So now I'm gonna win. Let's look at the evaluation. It's got best. It's taking 6 seconds per move. It's saying that best score -4. So it doesn't think it's won. It doesn't think it's lost yet. I think now it's gonna know that it's lost after I made this move. Okay, see that score there? Now it knows that it's lost because it's going to a depth of 7. So that's when I'm going to go here now because I've got 2 ways to win. It's going to move here because it's going to see that that move is going to score the same as these 2. Okay, so if I go here, I can choose where to win. Or I can, if I go here, I'm going to try and get 5 in a line. If I go there, it goes, I want it to go here, then I can get 5 in a line. Right, I might get 5 in a line now. Yeah, I should be able to, whoops. I missed that. Anyway, the computer beat me. However, a quick test for us to test if this is working is to see, look at these numbers, and they're the same as the other one. All of these numbers are the same, the positions. So we've now managed to translate that console into a graphic. It's a graphical interface. Now the only thing for us to do now is clean a few things up. Like for instance, what if I move and I move again and I move again? What happens? And it's the computer's move. See, have you remembered my move? What if I just do lots of moves like that? What happens? Okay, so what it is, I've got to clean it up so that when one person moves. Also, another thing is, I want it so that the person who moves first gets a red. That's another thing I need to clean up because if I just make it win, I was trying to make it win quickly, but it's just. So it won. So because it won, the side was still set to yellow. So because I went first, I'm getting yellow now. So I'm going to change that so that whoever goes first gets red. So I'm going to end this video now. At this stage, the game can be played because obviously I only have to add the extra thing for people who try to hack it. And I won't try to hack it, so I can happily play it like this with no problem. So I'm gonna end the video now. Until next time, bye.